I'm Raven, and in this video I'm finally going to get around to making a better power adapter for the models on top of my cabinet. But you see, I'm going to have several of these models, 4 in total, and right now they're all going to use an individual transformer, and that's 4 transformers, which is just wasteful. Really, all of these could be running from a single transformer. All I need is a junction box. Let's go ahead and make one. The general idea is I need a box which can connect all of my models to my power supply, rather than having 4 different power supplies just for each individual model. I need one for Voyager, Galactica, my Colonial Viper, and the USS Reliant, though we're a bit off from building that one just yet. And to keep that in line with the cabinets that I have, I want to tie it into an infrared sensor. Now I happen to have a whole bunch of infrared sensors left over from when I was making my cabinet, so there's no problem there. The key is going to be getting a box that's big enough to fit all of the components in, along with the ports, inputs, outputs, etc., and any circuit boards. So, here's some stuff I gathered earlier. I've got the box, I've got the sensor, and I've got the ports. Let's have a look-see here then. I got 5 right-angled connectors, 5 ports of the appropriate size. This is an IR sensor that I have salvaged from my cabinets. With this we're going to need to take purely the power, so this is a 4-pin LED driver, and we're just going to snip off the data and just use the power through the already established infrared. Change this for one of our nice right-angled ports, and it's all going to fit inside this rather nice little black box. First things first, we need to prepare this box. We're going to have 5 of these terminals in total, 4 of them along one side, another one over here, and then there needs to be a hole for the infrared sensor to poke through over here so that it can coil round and be seen. These ports require an 8mm hole, and well, getting those in this box is damned simple. We're going to draw a line, spot the holes, drill them through, poke them through, and then they just bolt on with this little hex nut. It's actually probably going to take longer to have made this section of the video than it'll actually take to do. That might be an exaggeration. We're going to want to have this line going right down the middle. So we'll take our ruler, mark off at 7.5mm on that side, and 7.5mm at this side, because this is a 15mm box. Then we'll just go ahead, swiggity swoop, connect the dots. There we go, nice and simple so far, I'm sure you're following along. Then these need to be 8mm holes. We're going to want to have them somewhat squished over to this side. So let's say if we give ourselves a centimeter from the edge, 5mm between, that should probably do the trick. So let's find our edge there. There's 1 centimeter. There's the center hole. So that's our first one. And now that we've got our first mark, to measure these across, we essentially want to have a perfect gap plus 5mm. So it's the length plus 5, which gives us 13. So our next center hole will be there, which, as you can see if I measure it out, that's where the edge will be, and there's 5mm between them. Exactly the same deal for the port on this side. We'll just measure 7.5 centimeters down. Now in this case we need the ports to be far more on this side so that there's space for the leg to come down here, because all of our ports will be jutting into this space. So let's give it 0.5 centimeter plus 4. So let's go here then as our center point. Now comes the interesting question of how to do the infrared lead. I could detach the cables from the PCB and feed it through a hole, but you'll note that in the original box that this came from, these little insets here slid down into a slightly rounded groove, and then this covered that hole and the entryway. And I'm inclined to do the same thing here. So what we'll do is we'll drill a hole, cut out the flak in a rectangle, and then when this slots down, these blanking bits here will cover the presence of that hole. Looking at the box, because of that screw hole, we will need to have it offset slightly to one side. But you can see that the box is a pretty good thickness for it, so it'll be a little bit tight, but that just means that it'll hold nice and firmly. We're looking at 1.5 centimeters. So we will need a hole just about here-ish. And the dimension of the cutout will need to be 4 millimeters. So I shall measure out 2 mil on either side of that. Last thing to do is carry that hole over onto the other side and figure out our depth, because this will only have to go down a certain amount, so there's no point drilling a hole halfway down it, because then the cable will never actually cover the bit we're supposed to be hiding. The depth of the hole is 5 millimeters, so we're going to want to drill down somewhere about here. Because we need to bear in mind the drill bit will be making a 4 millimeter hole, so there'll be 1 millimeter of cutout needing to be done. So it should be a nice, tight, and easy to do bit. And there we go. We're all fully marked up and ready to cut. I've got the old trusty Dremel out. First things first, I've got a very small drill bit. I'm going to drill some pilot holes. We're drilling some bigger holes here, so we're going to have to get the big boy tools out. Before I do the next hole, I just want to check the size of this drill bit against the insert. Looks okay. It may actually need to be a 5 mil hole. We'll find out soon enough. Before I put the drills away, I'm just going to cut this out and make sure that our lead actually fits. Yeah, that is not even close. That's way too small. So I'm going to go with, we need a slightly bigger drill bit. Now because we've already cut this groove out, it's not going to be easy to try and drill down into this. The drill will simply slip out and fly off wherever it wants to. However, what we can do is we can push the drill into the hole and we'll carve ourselves a nice 5 millimeter little bit there. Okay, now we've got our box and we've got all the various holes and bits that we need for it. We can look at the electronics. With all of our ports coming through, we're going to need to have a junction board which will take the power from this cable, which won't be here. This cable will stay exactly as it is, and then we need to take this bit off and replace it with one of these ports. That's just going to be done with a bit of danglier wire. So really, we need to create a little junction PCB that will just sort of sit on top of here. Solder on these connections to there, and we're pretty well sorted. To get us started, there's some very simple modifications we can do. First things first, we don't need this lead. Goodbye lead. And we do not require the green or blue cable, for they carry data intended for LED strips, and we are not using LED strips that require data. Goodbye. That leaves us with our positive and negative wires, which are indicated on the board, and our infrared sensor. However, that part of it is going to stay the same. Next up, we need to get rid of this port so that we can replace it with our own one. As you can see, 3 pins that hold it to the board. Should be a simple case of desoldering it. With that pesky thing off, now we just need to go ahead and butting in the wires. Okay, so we now have the way for our power to get in, we have a way for our power to turn on and off, and we have a way for our power to get out. That's all the modifications we need to do to the board. We need to bear in mind that we won't be able to put the end of the connector on until it is inside the box. Otherwise, we won't be able to get the end on. So, the next thing I'm going to do is this mid connector box and all of the ports that go along with it. It's literally just 4 straight bits going to a bit of copper board, which then junction on with the positive and negative. Something to bear in mind here is that according to the markings here, their black cable is their positive and their red cable is their ground. I tend to wire my stuff the other way around, so I will need to double check and make sure my polarities are good. To do that, I'm going to connect this up to a 12-volt power source and measure what is coming out of these, and then make sure that Voyager and my Viper are wired the same way. Okay, so I've stripped off the board, I've plugged in the wires, and all I need to do now, if we note here the voltage is 0, when I press the on button, boom, up to 12 volts. Boom, back off again. Perfect. So now all I need to do is create a PCB junction board that all of the ports will connect to, and then connect this to the actual port on the board itself. I've pre-stripped 5 pieces of wire, cut down a little piece of copper boarding, and I've got my 5 ports ready. What we're going to do is I'm going to solder the wires to the copper board first, poke the wires out through the holes, solder onto the ports, and then we can clamp those ports in. The reason for doing it in that order is it's going to be a lot harder to work with this piece of copper board if I'm restricted to around this container. Whereas this way around, we can poke the wires out and work fairly freely out here. And with the squid linked up and complete, I'm just going to take a little bit of insulation tape just to make sure that these 2 boards aren't going to interfere with each other. Just enough that these 2 boards can physically be near each other without any risk of any contact happening. The process from this point is very simple. We have our circuit boards inside the block. We're going to feed a pair of the wires through. The black cable is going to form the center pin, and the red cable will be the outer pin, the ground. We solder these on one by one, and then once they're all in, we'll slide them in, not forgetting to put the washer on first. Washer, bolt. And there we go. All wired in. All the ports are connected. The sensor is on. We're all good to go. Before I do seal this up, I'm going to take a little bit of double-sided sticky tape and just secure the circuit board to the bottom of the box. And there we go. One complete box. All that remains to do is seal it up. And there we go. One neat little box. It'll serve for all the models that I have, as well as a couple more that I'm yet to do. And it'll turn on at the same time that I turn my cabinets on. Or indeed, if I want to have it separately, it's still remote controlled. All I need to do now is attach things to it. Alright, we're back on the desk with Voyager. I just thought I'd immortalize the moment where I either have this working and it's all beautiful and happy, or I completely and utterly blow Voyager's circuitry up. It's always a fun moment. Okay, it didn't blow up. This is good. I was working on the assumption that it wouldn't blow up. Just make sure the remote control works. Boom, look at that. On. Off. Beautiful. That's going to do it for this video. I'll need to get a 5-volt transducer to hook my Viper up into the circuit, but that is just a simple case of installing a new chip. So, until next time, until we get back to Galactica, I'm Raven, and that's all from the lair.